Okay, it is just about midterm time, so we've got a couple review assignments here that are going to help get you ready for the midterm. Let's take a look at what we've got. All right, Tom drove 290 miles from his college to home and used 23.2 gallons of gasoline. His sister Ann drove 225 miles from her college to home and used 15 gallons of gasoline. Whose vehicle had better gas mileage? Justify your answer. All right, so this problem actually comes from Unit 3, which was about proportions. When you're talking about gas mileage, you're basically saying how far can you go on 1 gallon of gas. So this is a unit rate problem, and we're actually going to have to set up two separate proportions. So the way we did proportions is we made ourselves a keys. So I'm going to do miles over gallons, miles per gallon. That's usually how we talk about gas mileage. So Tom drove 290 miles and used 23.2 gallons of gas. I want to know how far would he get on just 1 gallon of gas. All right, that's what we usually refer to as gas mileage, and in this case, it's our unit rate. So if you remember, this is where we cross multiply. So I'm going to end up with 23.2x equals 290. Then I've just got to do that division. So divide by 23.2, divide by 23.2. X is going to equal 12.5 miles. So Tom is getting 12.5 miles per gallon. All right, must have a big car. It's not very good. Let's take a look at Ann's. All right, so this is Tom. Let's just label this with Tom. All right, so Ann drove 225 miles and used 15 gallons. So I'm basically using the same key that I used over there, miles over gallons. So we want to know how far would she get on just 1 gallon of gas. So again, we're going to cross multiply. 15x equals 225. Remember, when we're doing this, the equal sign just comes right down in the middle. Divide both sides by 15. Divide both sides by 15. 225 divided by 15 is just going to be 15. So she gets 15 miles. So this is Ann right here. So we want to make sure we actually answer the question. I mean, we showed this beautiful work, but now we want to say over here that Ann gets better gas mileage. All right, because Ann gets 15 miles for every gallon of gas that she has, and Tom only gets 12.5 miles. Okay. All right, so let's move on here. Jason's part-time job pays him $155 a week. If he already has saved $375, what is the minimum number of weeks he needs to work in order to have enough money to buy a dirt bike for $900? All right, so this is kind of like those money problems where we saw like a price times how many. In this one, we don't have a price, but we do know how much he makes per week. So that's going to be sort of like our price in this problem. So if we look at it, he has already saved $375. Well, let's slow down. What are we trying to find? We're trying to find the number of weeks he needs to work. So let's start with our let statement. Let x equal weeks. That's what we're trying to find. All right, now we can put something together. He has already saved $375, so he has $375. That much is set. We want to know how many weeks he has to work, and he gets $155 per week, or a week. So that's going to be plus that $155. Now, if it was just 1 week, we'd be done. 375 plus 155. But we don't know how many weeks he needs to work, so that's where the x comes in. these two numbers are going to get multiplied. So if he works 1 week, it's 155. If he works 2 weeks, it's 310, and so on and so forth. All right? Now he needs a minimum of $900. So that means we need this side. It doesn't have to exactly equal 900, but it has to be greater than or equal to 900. We need these two numbers when added together to be greater than or equal to 900. Otherwise, he's not going to have enough money to buy his dirt bike. All right, so we're in a place now where we can start solving. Minus 375, minus 375. So we get 155x is greater than or equal to 525. Divide both sides by 155. All right, 525 divided by 155 is going to be x is greater than or equal to 3.387096774. All right. So, does that mean that Jason has to work 3.387096774 weeks? Not exactly. What you're going to want to do is kind of go to the nearest integer that makes sense. So, in math terms, you might be thinking, well, that rounds down to 3. So does that mean Jason only needs to work 3 weeks? No, because that won't be enough money. If we look at this, this is saying x has to be greater than or equal to 3. So what that means, well, greater than or equal to 3.38, so that means 3 is not actually going to be large enough because 3 is less than this number. So what we're going to have to go with is 4. Jason is going to have to work at least 4 weeks to have enough money for his dirt bike. Okay. All right, let's take a look at number 3. Number 3 is thankfully not a word problem, but it is a longer equation. So this is where we want to kind of fall back on our DCMS. We start with distribution, so any distribution that we can do, we want to start with distribution. Then we're going to combine like terms. After that, we're going to move any variables. So if we need to move a variable from one side to the other. And then once we move the variable, we should be ready to solve because we should be back down to a two-step equation. So let's go through these. Step 1 is to distribute. So I'm going to take this 5 and I'm going to distribute to both of those pieces. Now over here, you might be saying, wait, do I distribute the 4? What you have to remember is there's actually that invisible 1 here. All right, so we're not distributing the 4, we're distributing what's right next to the parentheses, and it's that 1 that we just don't always write in there. So after our distribution, we're going to multiply these, so that's 10x minus 5, and then we still have this minus 3x equals 4 minus 2x, and then that is going to become a minus 3 because it's negative 1 times 3. Okay. Now we're moving on to distribution is done, so we're moving on to combine like terms. On this side, we can combine the 10 and the minus 3 because they both have x's. On this side, we can combine the 4 and the minus 3 because they both do not have x's. All right, so 10 minus 3x, remember they're on the same side, so we don't do opposites, we just combine them. This is going to be 7x minus 5. Same thing over here, we're not doing opposites, we're just combining, so 4 minus 3 leaves us with 1 minus 2x. All right, so there's our combined like terms. Now we have to move the variable. We have x's on both sides. We need them to be on the same side. So we usually move the smaller one. It means we'll have less negatives to deal with. So the opposite of minus 2x is plus 2x. So that's going to give us 9x minus 5 equals 1. And now we're ready to solve because it's just a two-step equation. All right, add 5 to both sides. 9x equals 6. Divide both sides by 9. And we're going to get x equals... Now, if you do this on your calculator, what you're going to see is 6 divided by 9 is a repeating decimal. So you have two choices. You either do 0.6 with the bar over it to show that it's repeating, or we can just math frac it and see that that works out to be 2/3. So x is 2/3, or the other way you could write this is x equals 0.6 repeating. All right, those are pretty much the same thing. Not pretty much, they are the same thing. Okay, so there we go. Let's take a look at the back. Peter begins his kindergarten year being able to spell 10 words. He is going to learn to spell 2 new words every day. Write an inequality that can be used to determine how many days D it takes Peter to be able to spell at least 75 words. All right, use this inequality to determine the minimum number of whole days it will take for him to be able to spell at least 75 words. All right, so a couple of things here. It says write an inequality, so we have to make sure that we write an inequality. If we write an equation, we will lose points. So we have to make sure that we're either using a less than, a greater than or equal to, less than or equal to, one of those symbols. Now the question is, which one do we have to do? Well, it says at least 75 words. So if we think about the way that we used to do these, we would write 74, 75, 76. Now if we have to spell at least 75 words, 75 is the bare minimum. All right, so we could write 75, we could write 76, but 74 would not be okay because that's not at least 75. So this is one of those things where we're going to have to do a greater than or equal to, because x would have to be greater than or equal to 75. So this is the symbol that we're going to have to use in our problem, the greater than or equal to. Now, let's go back to our problem. So they already told us our variable. They said, let D equal days. That's going to work out to be the number of days that we need to spend. All right, so at the start of the year, Peter can spell 10 words. So those 10 words are already in the bank. We already have those 10 words, plus 2 new words every day. So plus 2 new words every day. Now, if he only did it one day, that would be 12 words. But it's not just one day, it's an unknown number of days. So that's where our D comes in. Again, it's kind of like the price times the how many, but instead of a price, we have the words. So 10 plus 2D, then we already said was going to have to be greater than or equal to 75. Okay, so if we solve this, minus 10, 2D has to be greater than or equal to 65. Divide by 2, divide by 2. D is going to have to be greater than or equal to 32.5. And then since the problem says the minimum number of whole days it will take for him to be able to spell at least 75 words, we can't do this half day here, so we're going to go up to 33 days because 32 won't quite be enough. It has to be greater than or equal to 32.5, so that would be 33 days. Okay. All right, moving on. Consecutive integer problems. Find 3 consecutive odd integers such that the sum of the first and second is 5 less than the third. All right, so there's a lot going on here. All right, first of all, let's talk about consecutive integers. Consecutive integers are integers that are in a row. So when the problem says consecutive integers, you can just think of that as like 4, 5, 6, 7, where all your numbers are going up by 1. All right, they each go up by 1. Consecutive odd integers would be odd numbers in a row. So 5, 7, 9, 11. Those are all going up by 2. And that's something that sometimes weirds kids out because they're like, wait, they're going up by 2, but 2 is an even number. Yes, but odd numbers still go up by 2. 5, 7, 9, 11. Even numbers also go up by 2. 4, 6, 8, 10. The only difference is Here you're starting on an odd, so when you go up by 2, you stay odd. Here you're starting on an even, so when you go up by 2, you stay even. All right, so this one is 3 consecutive odd integers. So when we do our let statements, it's going to be let x equal the first number, let x plus 2, because odd integers go up by 2, equal the second number, and let x plus 4 equal the third number. Okay, so we've got all those in there. Now we actually have to do the translation, such that the sum is addition of the first and the second. So the first is really x, and the second is really x plus 2, is, remember, is our equal sign, 5 less than the third. And hopefully a little bell's going off in your head, because remember, less than is our turnaround word. So we're going to have to flip the order here. And then the third is actually referring to x plus 4, because that's our third let statement. So if we put this all together, it's going to be x plus 2, that's the sum of the first and the second, is 5 less than the third. So it's not going to be 5 minus, it's going to be x plus 4 minus 5. There's the third, and there's our we're lessening it by 5. Okay, so now we have an equation here. There's a lot of like terms we can combine. So here on this side we get x plus x, so that becomes 2x plus 2 equals, and then we've got a 4 minus 5, so that's going to become x minus 1. Now we've got x's on both sides, so we want to take care of that. So we'll subtract x. 2x minus x is 1x. So you can either write 1x or you can just leave it as x. Those are the same thing. Plus 2 equals negative 1. And then our last step here would just be to subtract 2 from both sides. X is going to be equal to, careful, negative 1 minus 2 is actually negative 3. Right, so x equals negative 3, but remember the problem asked us to find 3 numbers. So negative 3 is our first number, and then negative 3 plus 2, be careful, it's not going to be negative 5. Negative 3 plus 2 is actually negative 1. And now we have negative 3 plus 4. Again, negative 3 plus 4 is not negative 7. Negative 3 plus 4 is actually a positive 1. So those are our 3 consecutive odd integers. All right, so that takes care of that one. And here we are on the last problem. Ooh, and it's a good one. Solve 3 halves. 6x minus 2 is less than 7 minus x. So again, here we go with our DCMS. Distribute, combine like terms, move the variable, and then solve. Now, a lot of times kids will get freaked out because there's a fraction here. Do not get freaked out by the fraction. It works just the same as an integer, and we can use our calculator to do that multiplication. All right, we just go and type in 3 halves times 6. So that's 9, so that's going to be one of our distributions, and then we'll do 3 halves times negative 2 and get negative 3. So do not get intimidated by the fraction. It's the same distribution we're used to doing. So this one is going to be 9x, and then this one is going to be minus 3 is less than 7 minus x. So there's our distribution. We cannot combine these, so there's no combining like terms. Next we have to move the variable. I'm going to move this smaller one here, so I'm going to add x to both sides. Remember, that's really a 1x, so 9 plus 1 is just going to be 10x minus 3 is less than 7. And now we're ready to solve. So I'm going to add 3 to both sides. I get 10x is less than 10. Divide both sides by 10, and we end up with x is less than 1. Okay? So again, something that looked intimidating, really not that bad when you break it down. All right, this is the end of the first review homework. I hope it's going to help you get ready for the midterm. Have a good one.